Okay, let's start. Let's let's go to question 9. Question 9. So in question 9, we have, they say, a curve. So we have a curve such that dy dx equal to 4 over square root of 6 minus 2x. All right, and a point is on the curve. So there's a point P on the curve, which is at coordinate 1, 8. So this point is on the curve. All right, so now they say I'm figure 1. They say the normal to the curve at point P meets the coordinate at Q and at R. Find the coordinates of the midpoint. Say we have a graph. Graph can be like this. So we have the x-axis, we have the y-axis. Say we have a graph. This would be the curve. So this would be the curve, and then this curve. Okay, they say this is the point P, and then this will be a tangent to that point P, and the tangent to that point is the gradient, determines the gradient at that point. So, and then a normal, so a normal will be perpendicular to the tangent. So this will be the normal. So they say that the normal to the curve at point P meets the coordinate axis. So the coordinate axis will be the y-axis and the x-axis. So it meets at Q. Say maybe the point here is Q, this point, and the point here is R, right? All right. So find the coordinates of the midpoint of QR. So this will be the line QR. So we need to find the coordinates of the midpoint. So we need to find the midpoint of this line. So first we need to determine these points, and then we find the points midway. So here this equation is used to determine the gradient at any point. In this case, we can determine the gradient at the point P. So let's start. So we have, okay, so we have dy dx at point P, and then we need to substitute the values of the coordinate P. So in P we have 1, 8, where this x and this is y. So we need to substitute these values. In this case, substitute x here. So we have that maybe, okay, yeah, so we have that 4, and then square root 6 minus, so this should be 2 times 1. So this will be 4. This will be 6 minus 2, which is 4. So this will be 4 over 2. This is 2. So let's call this M1, and this is the gradient of the tangent. So this will be the gradient of the tangent, or the gradient at, or the slope at this point. So now, so we know that you can always find an equation that, or can always find a gradient that is perpendicular to that by this relation. I hope you remember this one. So where you use a gradient to find the one that is perpendicular, you use this relationship. So in our case, we have M1, which is this one, and so we can solve. So therefore, this implies that we can solve for M2, so using M1. So we know that M1 is 2, so that we have that M2 is negative half. So remember, so now we have a point or we have a gradient. Can we write? So we have now we have a gradient of the normal. The normal, which is this m2, is equal to -12, and also we have a point where this cross. So we have a point, this point where this x, this is y. So having a gradient and a point, you can find the equation. You can find the equation of the normal. So you use this relation where you have okay, in that case called m, and then we have x minus x1. So these points, will use these points. So where we'll put 8, we'll put y here, we'll put 1 here. So it will be 1 minus 8. So remember the gradient, so which is -12. So in this case, so this would be 1. This would be 1. So then you can multiply 2. So it will be 2y minus 8. Then multiply in the negative. So it's negative. Then this plus 1. So now, oh, this is 16. Sorry, this will be 16. And then, so we take this guy to that side. So we have negative x plus 1 plus 16. So now you divide by 2 both sides. So we have this equation. So this is 17. So 17/2. So now, since we have this equation of the normal, you can use this equation to determine these points. So let's maybe say if you can look closely here, this point, so r, so along this line, or along this axis, which is the x-axis, we have, if you can put coordinates. So here we have x being some number, let's call it a, and then we have y, the y part being 0 along this line. So, and then here to q, in q, so we have 0 on the x, but we have some number on the y. And since this is an intercept of this line, we can clearly say this is, you can see that b is actually this guy, actually 17/2. But we can always calculate it. We can calculate it instead of assuming, but we are sure. So in q we have 0 b. So remember we have this equation, which is -12x, if I'm not mistaken. -12x. All right. So -12x. So plus 17/2. So now, now we can. This is 0, so we put 0 here. This is b. Put b in y. So this would be 0. So of course that b, it goes without saying that b is actually 17/2. So our coordinate at q is actually 0, 17/2. All right. So let's go to the position r, where we have a and 0. So now we go back to this equation where we substitute. Okay, it's x is y. So for y we put 0, and then here we put a instead of x, so we have -a/2, then plus 17/2. So you can take this guy to that side by adding, so it will be a/2, 17/2. So when we multiply both sides, so this implies that a is actually 17. Therefore we have that r is actually the coordinate of r is actually 17, 0, 0. So now we have these points of the normal. So we can use this equation of finding a midpoint. So where midpoint midpoint is equal to, say, x1 plus x2 over 2 is equal, and comma, y1 plus y2 all over 2. So now here you close this. So now we can say take this one to be x1 and we take this one to be x2. So we have 0 plus 17 over 2, comma. So we can take the other one as y1, which is 17 over 2, and we take this guy as y2, which is 0 over 2. So, and then this will be 17 over 2. This will be 17 over 2 divided by 2, which is 17 over 4. So this will be the midpoint of QR. So now at Roman figure 2, we are required to find the equation of the curve. So remember that we were given that dy dx is equal to 4 all over 6 minus 2x, right? So when we want the equation of the curve, so we will need to integrate this, and then we'll have the equation of the curve. So we need to do this integral. So we need to solve for y. So we need to solve for this guy. So what we can do here, we can integrate this way. So we can multiply the dx. So we have dx here. So this would be 4 6 minus 2x, like this. Then we take the integral both sides, and then we need of course to add constant. So in this side we'll have y, so we need to find this integral. Okay, we need to find this integral. So this integral, so let me write it, square root of 6 2x dx as a constant. And then so what we can do now is to solve this integral. I'm not quite sure what methods you have covered, but the way I will tackle this problem will be, say, let u, because this thing is complicated. It's a complicated root. So what I can simplify it by letting the whole thing u. So let u be the square root of 6 minus 2x, right? So, and then of course, how do you remove a square root? By squaring both sides. So this will be u squared. So here will be 6 minus 2x. So now what I can do is I can take a derivative. So if I take a derivative this side, it will be 2u du. So in this side derivative will be 0. So in this side it will be minus 2, so dx. So, and then because in the integral there is dx, so I need to leave the dx, the subject of the formula, this side. So I will need to divide by 2 both sides, negative 2 both sides. So it will be negative u du is equal to dx. So now I take this guy, instead of dx I put this guy here, and instead of u I put this guy. So let me write the new form. So the new form now of the equation will be y. So y will be equal to the integral. So I can even take out the 4 out. So I can take the 4 out of the integral because it's a constant. And then so what is left inside is 1. So remember, this guy is u. I've let here that u is this square root. So this would be u. And then instead of dx we put this instead of dx, so it will be this guy. So clearly you can see that this will cancel this, right? So here we'll have 4, and then okay, we can take out, you can even take out the negative, so it will be negative 4, and then inside we will be left with 1, so it will be something like this. So so you know what is the integral of this, so you know that 1 can be something like this. So you know that when you take integral, you add 1 and then you take this thing, so this would be like this. So I think you know the form of an integral. So when you take an integral, say you take an integral of this guy, so this will be an integral. So this is same as saying okay, this would be n maybe. So this is the same as saying n plus 1, then dividing n plus 1, then of course add a constant. So this is how you do an integration. So here when you know that any number to the power 0 is 1, so the try here, when you take an integral of 1, you end up with x. You see that? So this would be x, so this would be x. So now we can write that negative 4x, then remember we add a constant. So actually this is u, in this case it's u because we are integrating with respect to u, so it will be negative 4u plus constant. But remember that u is actually the square root of 6 minus 2x, so we need to put that back. So this would be negative 4, and then square root 6 minus 2x plus a constant. So now we need to solve for this constant, and we know there is at least a point we know that is along this curve, which is the point 1, 8. This is x, this is y. So we need to substitute these values to this equation and solve for the constant. So in our case, we have 8 here, so negative 4. So here it will be 6 minus x is 1, so plus the constant. And then this will be 8, negative 4. Then this will be 4 inside, so square root of 4 is 2, then plus a constant. So this gives us 8, so negative 8 plus a constant. And then we can solve for c, so we take this guy that side, so by adding, so it's 16. This means that c is actually 16. So this means that the new equation, what is the on the form way? Okay, so it's negative 4. Remember that the equation is negative 4 square root of 6 minus 2x, then it was plus c. In this case we know that c is 16, so this will be the equation of the curve. So this is the equation of the curve. So we are done with the equation 9.